Alright, for example 1, we have the equation of an ellipse, and we are asked to find the exact values of the center, the foci, the vertices, and we want to graph the ellipse. Alright, first of all, let's determine the orientation. Does this ellipse have a vertical or a horizontal major axis? Alright, so what do we look for? Well, we're going to look for the bigger denominator. So the 9 is larger than the 4, so that means that the major axis is parallel to the y-axis. The y-axis goes up and down, so the orientation here is a vertical major axis. Alright, so I'm going to draw a little picture of an ellipse that's longer in the vertical direction. Alright, so let's determine the center. The center of the ellipse is going to be the h and the k. Remember, the h value always travels with x, so it's always x minus h, and then the k value always travels with y, so it's y minus k. Just like with the parabola, when the h and k value go into the equation, they change signs. So when we pull them out of the equation, they also change signs. So the h value then would be actually -4. Remember, even though it looks like a +4, when you pull it out, it looks like it changes sign, so it becomes a -4. And behind the y, we have a k value, we say -2, but it looks negative in the equation. It's going to change signs when we pull it out for the center. So -4, +2 is the center. We can go ahead and graph that. -4 for the x, +2 for the y, so there's the center. Put C for center. Or we can actually write out the word center. Let's do that. Okay. Alright. In order to figure out the vertices and the foci, we need to figure out A, B, and C. So what are the values of A, B, and C? Alright, so we said that the 9 was the larger, so that's automatically defined to be a squared. And the other value then is automatically assigned to be the b squared. Alright, so what is the a? So be careful of something. If we say a squared is 9, take the square root of both sides, a is going to be 3. If you want to do plus and minus, you can. But we're really considering these as distances. So if you think about it as positive or negative, it really doesn't matter. Alright, b squared is a +4. So what does b have to be to make that statement true? B has to be a +2. Alright, and if I want to know c, we have that formula. C squared equals a squared minus b squared. Alright, so our a value, you can even go even further and say, well, don't we know what a squared is? Do I really need to square 3 to get 9? No, we already know a squared is 9. So that's 9 minus b squared, and b squared is 4. So c squared equals 5. Take the square root of both sides, we get that c is equal to the square root of 5. And if you want to, you can say plus or minus. But we're talking about a distance, and usually we think about distance as being something positive. So those are A, B, and our C. So let's draw the vertices. Now before we do that, we need to remember that we're talking about a vertical major axis. So I'm just going to draw a vertical line to remind myself that on this major axis, I'm going to plot the foci and the vertices. Okay, so the vertices, remember, deal with the A value. The A value is 3, so I'm going to go up 1, 2, 3 units, plot a point. I'm going to go down 3 units from the center, 1, 2, 3, and I'm going to plot a point. Now, when we describe the vertices, we're looking for what's the ordered pair. So for the vertices, I would have -4. The y value of that point looks like 5. And -4, the y value of that bottom one looks like -1. Okay. Now let's go ahead and use the b value. The b value represents the endpoints of the minor axis. So what we just found were the endpoints of the major axis, those vertices. I labeled them V for vertices. Now let's go toward the endpoints of the minor axis. So they're going to go in the opposite direction, and I'll plot those. Let's do that in green, let's say. So we're going to go in the opposite direction to the left 2 units because B is 2, and we'll go to the right 2 units because B is 2. All right, we don't have to label those, but it does give us a nice idea of what our ellipse looks like. Once we have the A and B points plotted, we can actually draw the ellipse connecting those points. Okay, it doesn't have to be perfect, but do your best. All right, what about the foci? Okay, the foci are going to be the distance, represented by C, the distance from the center to each foci. So if I go up a distance of C, well, C is square root of 5. Let's think about what that is approximately. It's about 2.2. Now ultimately what we're looking for are the exact values, so we're not going to use the 2.2, but it's nice to have a little approximation to figure out approximately where should I plot the foci. So we're going to go up from the center along the major axis 1, 2, and a little bit more, so about 2.2. There's a focus. We're going to go down from the center about 2 units and a little bit more, and there's another focus. I'm going to zoom in a little bit. So how much did we go up? How much did we go up from the center? Well, we said about 2.2, but it's exactly, this distance here of C is exactly the square root of 5. And we went down from the center 2.2 units, which is exactly square root of 5 again. Alright, so what's changing here? If I were to think about those points, what's changing and what's not changing? What's the x value of this point and this point? Well, the x value for both of them is negative 4. Okay, so that's not going to change no matter how much I go up or down from the center. The x value along that line will always be negative 4. So what's actually changing for these 2 points is the y value as I go up and as I go down. Alright, so here's what we're going to do. We're going to say, well, what is the y value of this point as I go up? Well, here it's 2, right? The y value here at the center is 2. We went up square root of 5 units, and going up along the y-axis is adding. So that's 2 plus the square root of 5. Alright, well, what if I go back to the center and I go down? What happens to my y value as I go down? Well, as we go down, the y value gets smaller and actually decreases, so we're going to subtract square root of 5. Oops. What are we subtracting square root of 5 from? Well, we're going down from a y value of 2. So it's going to be 2 minus the square root of 5. These are what we call the exact values. And this is what I'll be looking for in your homework. Okay. Now what about the approximations? What if I just wanted to know approximately what these values are? Let's play around with that a little bit too. Well, the x value is still negative 4. The y value would be 2 plus, remember, square root of 5 we said was about 2.2. So it would be 2, that's the y value here, adding 1, 2, and then 0.2. So that would be about 4.2, approximately. So that's our approx. So that makes sense. If I start with 2, a y value of 2, and then I add 2 and a little bit more, that's 4.2 for that y value. Alright, now what about the bottom focus? The x value is still negative 4, that hasn't changed. The y value here is 2, and we went down 1, so that put me at a y value of 1, so I decreased by 1. Decreased by another 1, so that puts me at 0, and then I'm going to go down a little bit more, 0.2 more. That would actually put me at negative 0.2. And that's an approximation. Right, so you can kind of play around with the approximate values if you want to in your calculator, but in the end what we're looking for are those exact values. So it turns out there is a little bit of a formula for the foci, and we'll talk about that in just one second. Alright, so let's write down the foci. It's -4, and something that you're welcome to do is to write that the 2 points look almost the same. They're both 2 plus or minus the square root of 5. Alright, and that's the exact value that we're looking for. Now it turns out that if you have a vertical major axis, that the foci will always be the x value of the center, so it will be the h value. Remember, the h value is the x value of the center, and then it will be the k value plus or minus the c value. So if you have a vertical major axis, this will be the formula that you'll always use to find the foci. Okay? Something else that I want to point out is that when you look at all of those values on the line, do you notice there's something in common with all of those points? They all live on the major axis, which is vertical, and you notice they all have exactly the same x value. And that should make sense because along the vertical major axis, the x value is always going to be -4. It's always going to be the same. And that will always be true if you have a vertical major axis. The x values of the center, the vertices, and the foci will always be exactly the same. Alright, for this problem we are asked to look at the equation of the ellipse and find the exact values of the center, the foci, the vertices, and graph the ellipse. Alright, let's start out with the orientation. Alright, to determine if the ellipse will be longer vertically or horizontally, we want to look for the larger of the two denominators and look what variable that is under. 25 is larger than 16, and the 25 is underneath in part of the x fraction. So the major axis is parallel to the x-axis. Alright, so I'm just going to draw a little picture for myself and highlight that that is the major axis. Alright, let's find the center. Okay, remember that the center is going to come from the numbers that are after the variables x and y in the parentheses. And they're always going to change signs. So the center would be a +1 and then a -2. Remember, the center is the h, k. Alright, to find the vertices and the foci and to actually graph, we need to know what is A, what is B, and what is C. Alright, so the 25, since that's the larger of the two denominators, we assign that to be a squared. And then that means the other denominator is assigned to be b squared. So the a value would be 5, the square root of 25. The b value is the square root of 16, so that's 4. Okay, what's the c value? We're going to use that formula to find c. C squared is equal to a squared minus b squared. C squared is equal to, well, the a squared value is 25, so we'll do 25 minus. The b squared value is 16. 25 minus 16 is 9. The square root of 9 is 3. Alright, so how do we use all this information? Well, let's first plot the center. We have +1, -2, so here's the center. Alright, and we decided that we had a horizontal major axis. So I'm going to just draw a line that is horizontal, just to remind ourselves that everything that we care about is really going to fall along this horizontal line. Okay, so when we plot the vertices, that deals with A. Okay, we're going to go to the right 5 units. That's what A is. So 1, 2, 3, 4, 5. So we're going to go along the major axis to the right of the center 5 units, since A is 5. And we're going to go to the left 1, 2, 3, 4, 5 units as well. So we're going to go a distance of 5 to the left, 5 to the right, and those are the vertices. Okay, we want to label those points. What is that? -4 for x. The y value is -2. And for the right vertices, it looks like the x value is 6, and the y value is again -2. Alright, let's go to B now. B is going to go in the opposite direction of the major axis. And we want to plot the endpoints of the minor axis. So our B value is 4. We're going to go up 1, 2, 3, 4. We'll go down 1, 2, 3, 4 from the center. Alright, so that distance tells me how far to go from the center to the endpoints of the minor axis. We don't have to record those. Okay, now that we have all of those values plotted, we can draw the ellipse. Alright, doesn't have to be perfect, but we'll do our best. Alright, now what about the foci? For the foci, we're going to go along the major axis, starting at the center. We're going to go 3 units to the right. Alright, and we'll plot the focus 3 units to the right. Remember, that comes from the C value. We're going to go back to the center. We're going to go 3 units to the left. We'll plot that point, and there's the focus 3 units to the left. Alright, so what are those points? It's that -2, comma, y value of -2. And then the one on the right is 4 for x, and then the y value again is -2. Alright, remember we talked about a little formula for finding the vertices, so let's talk about that formula. If there is a horizontal major axis, then the foci will always be h plus or minus c, comma, k, where h and k are talking about the x and the y value of the center. So in this case, when we go to look for the foci, you'll notice that the y value of all of the points was exactly the same, right? So if you look at the y value of the center and the vertices and the foci, the y value stayed the same. And that's because they all fell along the same horizontal line, and all of those points were plotted at the same y level. The only thing that was changing is how we moved from the center to the right or to the left. And when you move to the right or to the left, the x value is what changes. So you'll notice that all of those points have different x values. So all of those points have the k value of the center. So how did we get h plus or minus c? Okay, so you start at the center that has an h value that has the same x value of the center, so that's 1. So what do we do to 1? Well, we added 3, right? So we move to the right 1, 2, 3. So that's h plus the c value. That's 1 plus 3, which gives us 4. So that's where that point comes from. That's the 1 plus the 3. It's the h plus the c. To get the -2, we started back at 1 at that h value, but we went to the left 3 units. So that's like subtracting the c value of 3. What is 1 minus 3? Well, that gives us the -2. So if you have a horizontal major axis, your foci will always follow this formula to get both of those points. If you can simplify to make those points look as nice as possible and still keep exact values, then you should simplify the foci. You should not leave it as 1 plus 3 or 1 minus 3. Because 1 minus 3 we know is -2, and 1 plus 3 we know is 4. So anytime you can simplify those values, then you should.